Bismillahirrahmanirrahim. So I thought we'd do some questions with the mid-segment theorem. So here's a question. It says DE is a mid-segment. That's given to us. So we have a triangle ABC, and we're told that the segment DA is a mid-segment. Now what that means is AD is congruent to DB, regardless of how they look, and BE is congruent to EC. So, okay, and then therefore that would make DE the mid-segment. Now, if you recall, the mid-segment is, we know two things about mid-segment. First, that it is parallel to the third side, and second, it is half the length of the third side. Okay. Now here we're told that the side DA is 3x plus 7, and AC is 7x plus 6. Okay, so we're asked to solve for x. That seems reasonably enough because you have to take 2 of DE's, that's 3x plus 7, to make 7x plus 6. There we go. So because you have to take 2 of these to make one of that. Okay, now if you had said that 1/2 of 7x plus 6 is equal to 3x plus 7, that would work too. Okay, then you would have to solve it that way. So, but either way, both approaches will work. Okay, but to me it seems easier to say 2 of those will give you one of those. Okay, and then we distribute, so it'd be like this. So this is 6x plus 14 equals 7x plus 6. Now I'm going to bring variables to one side, so I'm going to subtract 6x from both sides like this, and then I am going to have 14 equals x plus 6. Okay, and then I subtract 6 from both sides like this, and then I have x is equal to 14 minus 6 is 8. Right? Yes, there we go. So there we have it. So, you know, always important to go back and read the question, make sure you solve for the right thing. Here it asked us to solve for x, so we solve for x. If it had asked us to find the length of DE, then we would have to go back and substitute 8 over here in place of x and solve for the length of DE. Okay? So we have to always make sure we go back and read the question. Okay, so let's do some more examples here. So we're asked to find x, y, and z over here. Now here we recognize that we have basically mid-segment here, right? Because this is congruent to this, and this is congruent to this, correct? So we have mid-segment, okay? Then, okay, so the mid-segment we know is parallel to the third side and half the length of the third side. That's 20, so this must be 10. Okay, so we got the z. Okay, so x. What is x? Okay, well, x is that side over here, and that's a midpoint. So I said it's a midpoint over here. So x must be 8, right? So x is 8. And here y is also half of this segment over here. That's a midpoint, so these are congruent. So y is 10. So this is an example of a mid-segment theorem question. So here's another one. All of these. Now we're not told what we are, because look at this. That's 4 and 4. That means that's a midpoint here. And this is 6 and 6. That's a midpoint here. So this is a subtle way of saying that this is a mid-segment. Okay, if that's a mid-segment, then this x must be half the size of the third, half the third side, right? It'd be parallel 2, but they're not asking us over here. So this x should be 13 over 2. And there we have it. In question number 3 over here, again, we're given that we have a mid-segment. So you have to first recognize that, right? You can't go very far unless you recognize that you're dealing with the mid-segment theorem. So once you have that, the mid-segment theorem says the mid-segment is half the size. So this side here is going to be 20. Yeah, it's going to be 20. It's going to be twice as big as this. And here's another mid-segment question that's reasonably easy, it looks like. So over here, so okay, so 2 times 5 must equal to x plus 1, right? That's 10 equals x plus 1. Solve for x, subtracting 1 from both sides, you get x is equal to 9. So there we have it. Okay, how about these? Perhaps you can try these. if you want to, before we can go and do it together. Okay, so maybe you can take time and pause and then try these out before. All right, so now we know we're all about this whole worksheet is about mid-segment, right? So okay, we're asked to find x. Okay, that's x. Okay, so this is a mid-segment because that's a midpoint. That's a midpoint. So this side is 2 times this side, right? So 31 times 2 of those segments will give you 2x, right? And I'm just going to, oh, this is convenient because I could just divide both sides by 2 over here. Then I get x is equal to 31. Ta-da! Okay, that was not too bad. Okay, now this is an interesting question. Now this is a mid-segment over here, right? Because in this case, they all happen to be congruent over here like this. Okay, so first of all, we recognize that this is a mid-segment, right? So this side is 10. Okay, so this side is 10. We got that from over here. Okay, but then I'm supposed to find x. How am I going to do that? Well, then you see we have 60 degrees over here. This is an isosceles triangle, so this is 60 degrees over here also. That's because from the base angle theorem, if you remember, so that's the base angle theorem. Sides are congruent, then the opposite angles are congruent. The converse says that the angles are congruent and the opposite sides are congruent. Okay, so we got that. And then you recognize this is an equilateral triangle, 60, 60, 60. So all sides are the same. So therefore x must be 10. Ta-da. Okay, that's good. So let's do number 7 here. Okay. All right. This too looks like a mid-segment question, right? Because we have a midpoint here and midpoint here. We're connecting the two. In this case, we're asked to find these angles. Okay. Well, well, we know these are parallel, right? So these are parallel. The mid-segment is parallel to the third side, and it's half its length. If they're parallel, then we have a parallel line here, and a parallel line here, and this is a transversal going to them. And these are what angles? These are corresponding angles, right? So there's corresponding angles, so then they're congruent. So there you go, 60 there. And okay, now we have parallel lines over here and transversal over here. And how are these two angles related? Well, they are consecutive interior angles, right? So consecutive interior angles. So we have a consecutive interior angle theorem which says, it says, let me think, if you have a circle, no, if you have a parallel line that's cut by transversal, then the consecutive interior angles are supplementary. That's true, supplementary. So these two are supplementary. It's going to be 180 minus 40. That's going to be 140 degrees right there. Ta-da. Okay. So that's 140 degrees. That looks like that to me. Okay, that's pretty good. And let's see. Now this one is another algebraic one. I think you can solve this one. I think I'll leave this for you. And if you have trouble, perhaps you can ask this one for me. And okay, try this one. This looks like a mid-segment question as well, because you have basically midpoint here and a midpoint here and a midpoint here. Okay, so these are mid-segments over here, 25, those the ones that are labeled. Now we are asked to find x. Well, this segment over here, okay, is going to be half this length over here, right? Okay, so it's so this whole thing is going to be 50. That's it, I think. Right, it's a mid-segment, and it's going to be half the length. So each one of these is going to be 25 and 25. Okay, so we got that. It wasn't so bad. Okay, I'm going to do one more over here. This should be the last one, I think. Now, you're asked to again solve for x and y. I notice here, again, these are mid-segments. Okay, so y would correspond to this side, right? So I can say 2 times y, because it's going to be half this length, right? It's going to be 2x plus 1. Okay, that's going to be tough to solve because 2 variables. Okay, but look at this one, x and this one here. X, this segment here is also a mid-segment over here, so it's going to be half the length. So 2 of those, 2 times x is going to equal to 3x minus 6. Oh, that's going to be helpful, right? Because There's only one variable here. So this question is tricky because you have to recognize that if you go this route, it's going to be tough to solve. But if you look at this over here on the other segment, it's reasonably easy to solve that one. Okay, so I'm going to subtract 2x from both sides like this. And I'm going to get 0 equals x minus 6 and add 6 to both sides. And I get x is equal to 6. Now I found that. X is equal to 6. Then I can solve for y by substituting it over here. So 2 times y is equal to 2 times x, which is 6 plus 1. So I'm substituting 6 over here, see? So 2y equals 6 times 2 is 12 plus 1. So 2y is equal to 13. And y is equal to 13 over 2. And I hope I didn't make any math mistakes, silly mistakes over there. So that looks like 13 over 2. And that's it. Inshallah, next time we'll do some more interesting questions. Until then, as-salatu wassalamu ala rasulillah walhamdulillahi rabbil alamin. Assalamu alaikum.